Okay, so now that we know what our binomial coefficient and binomial setting look like, let's actually take a look at using our model to find some probabilities. So if x has a binomial distribution with n fixed trials and probability p of success on each of these trials, the possible values of x are 0, 1, and all the way up to n. If k is any one of these values, right, which k here represents the number of successes that we seek, then we have the following here. So let's suppose we know that x is binomial and we're looking for the successes here. So we're going to take the total number and we're going to choose the amount of successes. We're going to take the probability and the probability of success here multiplied by the times that it occurs, and then we're going to multiply this by the amount of times where the success does not occur. And on the AP Stats formula sheet, this might be a lowercase x, but remember these are just variables, they're just relative. So here we've defined k as the success rate, so the probability that the random variable that has a binomial distribution has this many successes would be equivalent to the total number of fixed trials, selecting the number of successes multiplied by the probability, the independent probabilities to the kth power, times the complement of the successes, which we call the failures, to whatever is remaining. So that's kind of how we read this formula in context. And an important thing here is that we can start at 0, because it is totally possible we have 0 successes in whatever our sample space is. So that is an important distinction for the binomial setting. So let's look at some examples here. Let's revisit the example from the previous video. Suppose each child of a particular pair of parents has probability 0.25 of having blood type O. Suppose the parents have 5 children. What are we looking for? So we've already verified that x has a binomial distribution here with 5 and success of 0.25. So again, these are my parameters for this distribution here. Find the probability that exactly 3 of the children have type O blood. Okay, so here's my sample space, right? I could have none of the children, 1 of the children, 2, 3, 4, and 5 of the children. And this makes up my sample space here. Well, I want the probability that exactly 3 children, if I were to list these 5 children in order, or even not in order, but essentially I'm picking 3 of them to have O blood, we can use our model. So now we would go into our probability statement. So we have x equals 3. And so this just looks like 5, choose 3. And the probability of success would be 0.25. And there's 3 successes times the complement here, which would be 0.75. And there are 2 failures. And when we do this, the probability of having exactly 3 children with type O blood would be 0.0879. So that's just an easy way to verify this with our model. Should the parents be surprised if more than 3 of their children have type O blood? To answer this, we need to find the probability that x is greater than 3. So again, looking at our picture here, the probability that x is greater than 3 would be the sum here of the probability of 4 children having type O and 5 children having type O. So we're going to rewrite that as a statement. So the probability that x is greater than 3 is the same thing as x equal to 4 plus the probability x is equal to 5. So this just follows a very similar model here from our random variable discussion back in 4.6. So again, for each section here, it's important to be able to set up the equation. For the AP Stat exam, typically there is one very brief section that includes the binomial distribution in the FRQ question, but also within the multiple choice sections there might be 1 or 2 that have a mention of the binomial distribution. And so that could be finding the parameters, which we'll talk about next, finding the probability, or specifically sometimes just being able to analyze the models that are given. So for example, it is important, you don't have to do these by hand every single time, but it is important to communicate the mathematics here. And so, for example, I know that having exactly 4 children with type O blood would be 5 choose 4 times the success rate here, 0.25 to the 4th, times 1 failure. And we're going to add this to the probability of having exactly 5. So 5 choose 5. We have 5 successes, and we have no failures. And when I do this, I obtain a result of 0.0156. Now, should we be surprised if more than 3 of their children have type O blood? I would say yes, because look at how small this percentage is, right? This is a 1.56% chance that more than 3 of their children will have type O blood. So it's so rare in occurring that, yeah, I would be surprised, because it's quite rare that this will happen. That means about 98% of the time this is not going to happen. So the fact that this does happen at all, right, we have some statistically significant evidence here that this might occur. And so notice these, this is about 0.08, this is about 0.01. In AP Stats, our big numbers are usually 5 and 10. 5 and 10%. So here we'll call anything less than a 5% chance of happening, we'll call that statistically significant, because it is extremely rare that it could happen, but it is still possible that it might happen. So for example, here it's totally possible you can have more than 3 kids with type O blood, but it would be extremely rare for that to be the case.